All right, so for this problem, number 23, I need to put it in the form of one of these trig substitutions that we have in this section. And those trig substitutions, you know, a squared plus x squared, or x squared minus a squared, or something like that. So it's not in that form. What I'm going to have to do to get this problem in that form is actually complete the square. I'm going to take, let me write complete the square. I'm going to take this x squared plus 2x plus 5 and use some algebra to get it in the form where it's a perfect square plus or minus some constant, and the constant I'll treat it as a squared, whatever the constant turns out to be. So for completing the square, I'm going to, in parentheses, group the x squared plus 2x, and I'll put my plus 5 at the end. And now what I'm going to do is complete the square on x squared plus 2x. To complete the square step, I'll put plus blank. The complete the square step is this. You take the number that's in front of the x to the first power, you cut it in half, and you square it. So I'm going to take 2, cut it in half, and square it. So that's going to be 1 squared, and that's going to be 1. So I'll put a 1 right there. Now remember, you cannot change the problem. I'm adding a 1, so what do I have to do over here? I got to subtract a 1. So my complete the square part, this factors into a perfect square, and it's going to be x plus 1 squared. Now what's 5 minus 1 is 4. So this is plus 4. There's my perfect squares. Under this square root sign on problem 23, we're going to have the square root of x plus 1 squared plus 4. I'm going to do a u substitution. I'm going to say, let u equal x plus 1. And then what is du? du equals dx. So now for this problem, number 23, I'll have the integral, the dx, the du dx, I'm going to write it on the side here. dx becomes du. I'll have a 1 in the top, and this will be the square root of u squared plus 4. Now I can work it using the techniques in this section. So I have u squared plus 4. For the trig substitutions, that means I'm going to use a tangent theta. So now for this substitution, I'll say this. U equals, by the way, what is a? It's going to be 2. U equals 2 tangent theta. Oh, no, I don't want to use a u. Oh, yes, I do. Yes, u is my independent variable now. U equals 2 tangent theta. What is du? 2 secant squared theta d theta. By substituting the expression with theta in the problem, I'll have the integral of 1 over 2 tangent theta, that whole thing squared, plus 4, and du is 2 secant squared theta d theta. I'll go back to putting it in the top just because of the space there on the page. Simplify it. Under the square root, I have the square root of 4 tangent squared theta plus 4. And that's the denominator. The numerator is 2 secant squared theta. Factor of 4 out of that square root. So this will be the square root of 4 times the square root of tangent squared theta plus 1. And the top is 2 secant squared theta. Well, the square root of 4 is 2, so I can reduce that 2 on the bottom with the 2 on the top. And what about tangent squared theta plus 1? Secant squared theta. So that on the bottom is the square root of secant squared theta, which is going to be secant theta. So I got secant squared theta over secant theta d theta. That reduces to the integral of secant theta d theta. We found the antiderivative of secant theta d theta a few class periods ago. And so you need to think, okay, what was that? It is the natural log of what? Secant theta plus tangent theta. And then I'll put on the plus c. At this point, I've got to go back to u, and after I go back to u, I have to go back to x. So I'm gonna use a new page for this, and I have up here that let's go back to u first. U was 2 tangent theta, so u over 2 is tangent theta. From here, draw the triangle. Now tangent theta is opposite over adjacent. So the opposite side is u, the adjacent side is 2. To get the hypotenuse, you could use the Pythagorean theorem. In fact, what's it going to be for the hypotenuse? The square root of u squared plus 2 squared, which is 4. So from the triangle, I'm going to read secant theta. Secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse, the square root of u squared plus 4 over adjacent. Tangent, you could read it from the triangle, but if you notice, you also have tangent right here already. Tangent is u over 2. And then plus c. Not quite done yet because we have to go back to x. And I'm looking back at the previous page. Remember that u equaled x plus 1. So every u will turn to, we'll write x plus 1. So the natural log of x plus 1 squared plus 4 over 2 plus x plus 1 over 2 and then plus c. Here's the answer to number 23.